Hello students, myself Professor S.J. Raymond from Department of Civil Engineering, KLS PDIT, Halia. Students, in the last class we have discussed about the disposal of effluents by dilution. So related to that, initially we have discussed about the objects of sewage disposal. The main objectives of sewage disposal are first one, to eliminate or reduce danger to the public health by possible contamination of water supplies. Second one is to render the sewage inoffensive without causing odor or nuisance. And thirdly, I can say to prevent the life of fish or other aquatic life by allowing raw sewage into bodies of water as such. The destruction of fish and other aquatic life can be prevented by the sewage disposal methods. With proper sewage disposal, the environment or the areas does not become polluted. Sanitary conditions are maintained in the area. There are two principal methods of sewage disposal by utilizing the natural agencies. First among them is dilution, that is disposal of sewage or wastewater in water here, which is nothing but our today's topic. And another method is land disposal or irrigation. Both the methods are very simple, but these may be regulated carefully so that the quantity of sewage put in water or applied to land is such that they are capable of receiving the organic load present in the effluent. Now, let me discuss in detail about the first method of disposal of sewage or wastewater, that is dilution or disposal of sewage or wastewater in water. Dilution is the disposal of sewage by discharging it into large bodies of water like sea or ocean, streams, rivers, etc. This method is possible only when the natural water is available in large quantity near the town. Proper care should be taken while discharging sewage or wastewater in water so that sewage may not pollute natural water and make it unfit for any other purpose like bathing, drinking, irrigation, etc. And also we have discussed about the favorable conditions to use this particular method. First condition is first favorable condition is that when the sewage is comparatively fresh, you can use this dilution method. And also when the diluting water is having high dissolved oxygen concentration, that is DO content. Third one I can say is where diluting waters are not used for the purpose of navigation. Fourth one, where the flow of currents of diluting water are favorable, causing no deposition, nuisance or destruction of aquatic life. Fifth favorable condition is that when the outfall of sewer of the city or the treatment plant is situated near natural waters. Now, before discussing the actual processes involved in the dilution, let me discuss about the types of receiving waters for dilution purpose here. And we have got different types of receiving waters or natural bodies of water here. First among them is lakes, second one is estuaries, third one is creeks, fourth one is perennial rivers or streams, fifth one is ocean or sea. These sources of water are probably the best type of receiving waters since the water is in continuous motion. Also, in the natural streams, there is a balance between plant and animal life with considerable interaction among the various life forms. However, the discharge flowing during summer and during winter varies. During summer, there may be minimum flow in the stream, so the dilution factor may be low, and also high temperature of water may result in low solubility of oxygen, necessitating proper treatment before dilution here. Let me discuss in detail about lakes here. That is, sometimes, especially when the perennial streams or rivers are not available, lakes may be used for dilution here. Various characteristics of lakes, such as its size, shape, volume of fresh water flowing into it, etc., should be critically examined before deciding the self purifying capacity. Now, next type of water resource is creeks. A creek is in the form of an inlet of sea coast, which may not have dry weather flow during some part of the year. Due to this, great care should be taken in disposal of effluent into it. Third one is estuaries. Estuary is a wide lower tidal part of the river, and the dilution in an estuary is affected both by ocean water as well as river water. However, the process of dilution is generally satisfactory in estuaries. Now, next water resource is perennial rivers or streams. These are probably the best type of receiving waters since the water is in continuous motion. Also, in the natural streams, there is a balance between plant and animal life with considerable interaction among the various life forms. However, the discharge of flowing during summer and during winter varies. During summer, there may be minimum flow in the stream. There may be minimum flow in the stream, so the dilution factor may be low, and also high temperature of water may result in low solubility of oxygen, necessitating proper treatment before dilution. Now come to the next type of water resource, that is ocean or sea. Ocean or sea water normally contains 20% less oxygen than that contained in fresh water of a river stream. Moreover, sea water normally contains large amount of dissolved matter. As such, the capacity of sea water to absorb sewage solids is not as high as that of fresh water of a stream. Moreover, sewage solids, when thrown into sea water, chemically react with dissolved matter of sea water, resulting in precipitating some of the sewage solids, giving a milky appearance to the sea water and forming sludge banks. These sludge banks are undesirable as they are likely to produce offensive hydrogen sulfide gas by reacting with the sulfate rich water of the sea. As pointed out earlier, the oxygen content of sea water, fresh water, and also its re-aeration is lower. However, since the sea contains two larger volumes of water, most of these deficiencies get removed, provided the sewage is taken up deep into the sea and away from the coastline. And also, since the specific gravity of the sea water is greater than that of sewage and temperature of the sea water is lower than that of sewage, the lighter and warmer sewage will rise up to the surface when thrown into the sea water. This will result in spreading of the sewage at the top surface of sea in a thin film. It is also known as sleek, that is SLEEK, sleek. To prevent the backing up and spreading of sewage on the seashore, the sewage should be preferably be disposed of during low tides. Large sized tanks may therefore sometimes be constructed to hold the sewage during high tides. Provision of a large size sewer grated with a non-return valve at the outfall end is also an alternative to hold the sewage during high tides. And also we have to keep some points before the sewage or wastewater is discharged into the sea here. First among them is the sewage should be discharged in deep sea only. In order to mix up the sewage properly with the sea water, the sewage should be released at a minimum depth of 3 to 5 meters below the water level, and by taking it sufficiently inside, about 1 kilometer from the shore, will prevent the sewage from accumulating on the shore. And third one, I can say, before deciding the position of outfall point, the sea currents, wind direction, velocity, etc. should be thoroughly studied. The point of disposal should be such that the sewage is taken away from the shore by the winds and not brought back near the shore. And fourth one I can say is the outfall sewer should be placed on a firm rocky foundation and encased in thick stone machinery so as to properly protect it from wave action, floating debris, etc. The discharge of wastewater into the sea should, however, be controlled in respect of quality of the effluents by adhering to the prescribed standards. The standards prescribed by BIS, that is Bureau of Indian Standards, under IS 1968-1976, also we have discussed. If you want, you can refer the class notes of the previous class. And also we have discussed about one of the example, that is the sewage disposal into the sea at Mumbai city. And apart from these topics, also we have discussed about the standards of dilution for discharge of wastewater into natural water resources. It may be rivers or streams. Before that, we have discussed about one of the important factor, that is dilution factor. The ratio of the quantity of the diluting water to that of sewage is known as the dilution factor, and depending upon this factor, the Royal Commission report on sewage disposal has laid down few standards and degrees of treatment required to be given to a particular sewage. So that has been displayed in the table of the previous notes, just to refer that particular previous class notes. Okay, this is what we have discussed in the last class. Apart from this, also we have discussed about the different characteristics of wastewater before it is discharged into the natural waters. And if you want, you can refer the table displayed in the last class notes. Now, today we'll discuss about another two important topics. That is, first one is self-purification phenomena, and second one is zones of purification in flowing waters. First, you come to the self-purification phenomena. When the sewage is discharged into a natural body of water, this receiving water gets polluted due to waste products present in sewage effluents. But the conditions do not remain so forever, because the natural forces of purification, such as dilution, sedimentation, oxidation, reduction, sunlight, etc., go on acting upon the pollution elements and bring back the water into its original condition. This automatic purification of polluted water in due course is called self-purification phenomena. However, if the self-purification is not achieved successfully, either due to too much of pollution discharged into it or due to other causes, the river water itself will get polluted, which in turn may also pollute the sea where the river outfalls. The various natural forces of purification which help in effecting self-purification process are: first one is physical forces. First one is Among physical forces, first one is dilution and dispersion, second one is sedimentation, third one is sunlight. And this particular sunlight will act through biochemical reactions. And second forces are chemical forces aided by biological forces, also called as biochemical forces. First among them is oxidation, second one is reduction, and now let us discuss in brief about these forces here. First among them, first physical force, that is dilution and dispersion. When the putrescible organic matter is discharged into a large volume of water contained in the river stream, gets rapidly dispersed and diluted. The action thus results in diminishing concentration of organic matter and thus reduces the potential nuisance of sewage. When the sewage concentration is Cs, flows at a rate of Qs into a stream with concentration Cr flowing at a rate Qr, the concentration C of the resulting mixture is given by, that is, CSQS plus CRQR is equal to C into QS plus QR. So then after simplification we will get C is equal to CSQS plus CRQR divided by QS plus QR. So this is very important in solving the numericals over the pollution of the rivers due to discharge of sewage or wastewater into the natural water body. This equation is applicable separately to concentration of different impurities such as oxygen content, BOD, that is biological oxygen demand, suspended sediments and other characteristics contents of sewage. Second physical force is sedimentation. The settleable solids, if present in sewage effluent, will settle down into the bed of the river near the outfall of sewage, thus helping it the self-purification process. Third physical force is that the sunlight. The sunlight has a bleaching and stabilizing effect of bacteria. It also helps certain microorganisms to derive energy from it and convert themselves into food for other forms of life, thus absorbing carbon dioxide and releasing oxygen by a process known as photosynthesis. The evolution of oxygen in river water due to sunlight will help in achieving self-purification through oxidation, which is discussed as below here. That is next physical force that is acting on the sewage when it is thrown into the natural water body, that is oxidation. The oxidation of the organic matter present in sewage effluent will start as soon as the sewage outfalls into the river river water containing dissolved oxygen. The deficiency of oxygen so created will be filled up by the atmospheric oxygen. The process of oxidation will continue till the organic matter has been completely oxidized. This is the most important action responsible for affecting self-purification of rivers. Next physical force is reduction. Reduction occurs due to hydrolysis of organic matter settled at the bottom either chemically or biologically. Anaerobic bacteria will help in splitting the complex organic constituents of the sewage into liquids and gases and thus paving the way for their ultimate stabilization by oxidation. The automatic purification of natural water is known as self-purification. The self-purification of natural water system is a complex process that often involves physical, chemical and biological processes working simultaneously. The amount of dissolved oxygen, that is DO, in water is one of the most commonly used indicators of a river health. As DO drops below 4 or 5 mg per liter, the forms of life that can survive begin to be reduced. A minimum of about 2.0 mg per liter of dissolved oxygen is required to maintain higher life forms. A number of factors affect the amount of dissolved oxygen, that is DO, available in river. Oxygen demanding wastes remove DO. Plants add DO during day but remove it at night. Respiration of organism removes oxygen. In summer, rising temperature reduces solubility of oxygen, while lower flow rates reduce the rate at which oxygen enters the water from atmosphere. Now let us discuss about the factors affecting the self purification. First among them is dilution. When sufficient dilution water is available in the receiving water body where the wastewater is discharged, the DO level in the receiving stream may not reach to zero or critical DO due to availability of sufficient DO initially in the river water before receiving discharge of wastewater. Second one is current. When strong water current is available, the discharge wastewater will be thoroughly mixed up with stream water, preventing deposition of solids. In small current, the solid matter from the wastewater will get deposited at the bed following the decomposition and reduction in DO. Third one is temperature. The quantity of DO available in the stream water is more in cold temperature than in hot temperature. Also, as the activity of microorganism is more at the higher temperature, hence the self purification will take less time at hot temperature than in winter. Fourth one is sunlight. Algae produces oxygen in presence of sunlight due to photosynthesis. Therefore, sunlight helps in purification of stream by adding oxygen through photosynthesis. Next factor is rate of oxidation. Due to oxidation of organic matter discharged in the river, DO depletion occurs. This rate is faster at higher temperature and low at lower temperature. The rate of oxidation of organic matter depends on the chemical composition of organic matter present in the wastewater or sewage. Next factor is hydrography. The hydrography affects the velocity and surface expanse of the river. High velocities cause turbulence and rapid reaeration, while large surface expanse will also have the same effects. The larger the amount of dissolved oxygen present in water, the better and earlier the self purification will occur. The amount and the type of organic matter and biological growth present in water will also affect the rate of self purification. Algae, which absorb carbon dioxide and gives out oxygen, is thus very helpful in the self purification process. The rate of reaeration, that is, the rate at which the DO deficiency is replenished, will considerably govern the self purification process. The greater is the rate, the quicker will be the self purification, and there will be no chance of development of anaerobic condition. Now, let us discuss about the second topic of today's class, that is zones of purification in flowing water resources. A polluted stream of river undergoing self-purification can be divided into the four zones. First among them is zone of degradation, second one is zone of active decomposition, third one is zone of recovery, and fourth one is zone of cleaner water. Now we'll discuss in brief about all these zones here. First, let us discuss about first zone, that is zone of degradation or zone of pollution. This zone is found for a certain length just below the point where the sewage or wastewater is discharged into the river stream. This zone is characterized by water becoming dark and turbid with formation of sludge deposits at the bottom. DO is reduced to about 40% of the saturation value. There is an increase in carbon dioxide content. Reoxygenation, that is reaeration, occurs but is slower than deoxygenation. These conditions are unfavorable to the development of aquatic life, and such algae die out, but fish life may present feeding on fresh organic matter. Moreover, certain typical bottom worms such as Limondrellus and tubifex appear with sewage fungi such as Tilasne tons. Now come to the second zone, that is zone of active decomposition. This zone is marked by heavy pollution. It is characterized by water becoming grayish and darker than in the previous zone. DO concentration falls down to zero and anaerobic condition may set in with the evolution of gases like methane, carbon dioxide, hydrogen sulfide, etc. Bubbling to the surface with masses of sludge forming an ugly scum layer at the surface is the indication of this particular zone. As the organic matter decomposition slackens due to stabilization of organic matter, the reaeration sets in and DO again rises to the original level, that is up to 40%. In this zone, bacteria flora will flourish. At the upper end, anaerobic bacteria will replace aerobic bacteria, while at its lower end, the position will be reversed. Protozoa and fungi will first disappear and then life will be absent. Algae and tubifex will also mostly be absent. Larvae of maggots and cycoda, that is one of the sewage fly, will however be present in all but the most septic sewage. Third one is, that is zone of recovery. In this zone, the river stream tries to recover from its degraded condition to its former appearance. The water becomes clearer and so the algae reappears with fungi decreases. BOD falls down and DO content rises up above 40% of the saturation value. Protozoa, rotifers, crustaceans and large plants like sponges, bryozoans, etc. also reappear. Bottom organisms will include tubifex, mussels, snails, etc. The organic material will be mineralized to form nitrates, sulfates, phosphates, carbonates. Now come to the last zone, that is zone of cleaner water. In this zone, the river attains its original condition with DO rising up to the saturation value. Water becomes attractive in appearance and game fish, which requires at least 4 to 5 mg per liter of DO, and usual aquatic life prevails. Some pathogenic organisms may still, however, survive and remain present, which confirms the fact that when once a river water has been polluted, it will not be safe to drink it unless it is properly treated. The stage of self-purification process can be determined by the physical, chemical and biological analysis of the water. Color and turbidity are the physical indices, while DO, that is dissolved oxygen, BOD, that is biochemical oxygen demand, and suspended solids, that is SS, are the chemical indices which can mark the stages of purification. Moreover, the biological growth present in water can also indicate the stage of purification process, as different types of micro and macroorganisms will exist in polluted water under different conditions. Students, if you want some more information about the self-purification and other topics, you can just refer the books listed here. And these topics are very important in sanitary engineering and in municipal services, and also if you want to work as a consulting environmental engineer. Thank you one and all.